Alright, we're going to start with Chapter 6, Lesson 1, Powers and Exponents on page 433. So please open up to page 433. It should look like this. The first thing we're going to do is talk about vocabulary. Before we get into their vocabulary startup, I want to talk to you about our vocabulary startup. We're going to be talking about the word factor. And I need you to remember that factor is in our multiplication problems. We've got a factor times a factor equals a product. So I want you to remember that that's what factors are. They're the pieces in a multiplication problem to solve to find the product. Okay, so now when we come over here and we read this, a product of like factors can be written in exponential form using an exponent and a base. We're saying that we're talking about a product of like factors. We're talking about a product of like factors. So that means numbers that are the same. And that it's going to be written in exponential form using a base and an exponent. And here it tells us that base is the number used as a factor. So remember, these are our factors here. The numbers in a multiplication problem. Those are our factors. So a base is the number used as a factor. And the exponent is the number of times that the base is used as a factor. So if we have 10 times 10, that's going to be 10 to the second power. So I want you to pause this and I want you to fill in the boxes with the words factors, exponent, and base. And we'll come back and check and see if you got it right. Alright, so these are our factors. Our 10s are the factors, just like over here in this example. The 10 we're going to use as our base. And the 2 is our exponent. It's the number of times that the base is going to be used. So when we do 10 times 10, we can also write that as 10 to the second power. Now the next one says, give an example of an exponent. So I want you to go ahead and give an exponent example. Alright, let's say it's 10 to the third power. This is our exponent. We could have also used an example like 3 to the fourth power, where the 4, again, is the exponent. And make sure that you're making it obvious that this is our little number that's raised up to the top of the right. Now it says write the definition of exponent in your own words. Alright, so basically for number 3, your answer should be something around the lines of how many times a base is used as a factor. Okay? How many times the same factor is used in a multiplication problem, something along those lines. Alright, and MP3 players come in different storage sizes, such as 2 gigabyte, 4 gigabyte, or 16 gigabyte, where gigabyte means gigabyte. 1 gigabyte is equal to 10 times 10 times 10 times 10 times 10 bytes. What is the number written with exponents? So instead of having to write out 10 times 10 times 10 times 10 times 10, blah, 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 they're saying that let's rewrite it kind of shorthand and use an exponent. So we need to think about what is our base. So when we have, I'm going to rewrite this here. We've got 10 times 10 times 10 times 10 times 10 times 10, and we count them 1, 2, 3, 4, 5, 6, 7, 8, 9 times. When we're rewriting this as an exponent, or a number written with an exponent, we would call it, first of all, what's the base? Because we always need our base, and then our exponent. So our base would be 10, because that's the number that's being multiplied. And how many times is it being multiplied? If you count how many times it's being multiplied, we raise it to that power. So this is 10 to the 9th power. Notice how I've got my 10 down here, and my 9 is written as a subscript up high. Alright, so writing products as powers, this is a really good visual for people that are visual learners. It says numbers are expressed using exponents are called powers. For example, 100 is a power of 10 because it can be 10 times 10, which is written as 10 to the second power. Numbers like 100 are perfect squares because they are squares of whole numbers. So here's another example of a perfect cube, which is 3 identical whole number factors, 4 times 4 times 4, so it's 3 times, that's a cube. which would be 64. So when they're saying a perfect square is when we have a whole number, such as, let's say, 9, and written to the second power. So it would be 9 times 9, okay, which would make 81. So 81 is what we call a perfect square, because it's really 9 squared. Numbers like 4.5 or 6.3, those numbers wouldn't be perfect squares because they do not have whole numbers. And that's just a little fun fact that's not something necessarily that you need to use now, but you will be using that in the future. All right, so we say number 1 here, example number 1 says write 6 times 6 times 6 times 6 using an exponent. So remember, the first thing we need to do is find our base and then figure out the exponent. So our base is the factor that's repeated in multiplication. Remember, our factors are numbers that are multiplied. So we have 6 times 6 times 6 times 6. So obviously our base is 6. And then we count how many times that 6 appears. It's 1, 2, 3, 4 times. So up here for our little number, it's a 4. So it's 6 to the 4th power. So 6 to the 4th power is not 6 times 4. It's 6 times 6 times 6 times 6. And this is something that you're going to get used to seeing. And I need you to understand that 6 to the 4th power is not 6 times 4. It's 6 times itself 4 times. Okay? So now we've got 4 times 4 times 4. And they want you to write that using an exponent. So we need to figure out what is our factor. That's the number that's repeated. And so in this case, it's 4. And then the factor is multiplied. Sorry about that. Hold on. Okay, sorry about that. So the factor is multiplied blank times. So now we're just counting how many times it appears. 1, 2, 3 times. And so the exponent is 3. So our base is 4, and our exponent is 3. So 4 to the 3rd power. That doesn't mean 4 times 3. See, it means 4 times 4 times 4. And that's something that you really need to get clear. It is not 4 times 3. Okay? Maybe you guys should write that down, because I feel like this is something you really need to remember. It is not 4 times 3. And put big X's through it. Okay? It is 4 times 4 times 4. Remember, we can do our multiplication sign with those dots. All right, now you're going to do the got it on your own. When you come back, we'll go over it. Okay, so it says to write each product using an exponent. A says 7 times 7 times 7 times 7. And so the first thing, remember, that we need to do is find the base and then the power. So the base here is going to be the 7s. It's the number that's repeated in the multiplication problem. And the exponent is going to be how many times that occurred. And so your answer for A should be 7 to the 4th power, which again does not mean 7 times 4, because 7 times 4 is 28. 7 times 7 is 49, times 7 times 7 is even more. So this is not the same as 28. 7 to the 4th power. Now for B, again, the two things we're looking for are the base and the exponent. The base here, 9 times 9 times 9 times 9 times 9 times 9 times 9. I hope that you notice that 9 is your base. And looking for that exponent, we're going to count how many times 9 comes up. 1, 2, 3, 4, 5, 6, 7. And so our answer is 9 to the 7th power. Not 9 times 7. Repeat that with me. Not 9 times 7. But 9 times 9 times 9 times 9 times 9 times 9 times 9. Which is definitely not 63. Just want to make sure you remember that. Alright. So the next one, it says write powers as products. To write powers as products, determine the base and the exponent. The base of 10 to the 2nd power is 10, and the exponent is 2. To read powers, consider the exponent. The power 10 to the 2nd power is read as 10 squared. or you can honestly also call it 10 to the second power. Or you can also say 10 to the third power as 10 cubed. Okay, we have a lot of different powers. 2 and 3 are not the only ones, so you can use them as the power of 2, the power of 10, the power of 13, whatever it is. But when it's telling you to write the powers as products, determine the base and the exponent, we're talking 10 times 10 would be 10 squared, which is also 100. All right, so for example number 3, it says 5 squared, or 5 to the second power, as a product of the same factor, and then find the value. It's really important that you understand that there's actually 2 answers here. One answer is writing it as a product of the same factor, and then the second answer is then finding the value. So our first part here when we're doing 5 squared is recognizing that the base is 5 and that the exponent is 2, so the base, the 5, is going to happen 2 times. So we've got 5 here, we multiply those together. And hopefully you know that 5 times 5 is 25. Let's look at another example. Write 1.5 to the third power, or cubed, as a product of the same factor, and then find the value. So we're writing it out, and then we're finding the value. Now, we have to figure out which is the base and which is the exponent. Hopefully you know by now that this beautiful little 3 up here represents 1, 2, 3 times that it's going to occur. And then our base is 1.5. So we fill in those blanks, 1.5, 1.5, 1.5, and we're going to multiply these. Okay, because remember this is not an addition problem, because that would be repeated addition. That would be 1.5 times 3. This is 1.5 to the third power, because we have 1.5 as our factor 3 times. Now when you're figuring that out, obviously you would need to work out 1.5 times 1.5, find that answer, and take that answer and do it times 1.5. And in the end, your answer is going to be 3.375. So notice that multiplying with decimals, it's coming back. All right. This next one says write 1/2 to the third power as a product of the same factor, then find the value. So again, 2 things that they're asking for, writing it and then finding the value for it. If it's 1/2 in parentheses, all to the third power, then we're going to have 1/2 times 1/2 times 1/2, 1, 2, 3 times. And so 1/2 times 1/2 times 1/2, if we're going to solve this out, we're going to now multiply all our numerators. And so 1 times 1 times 1 is 1. And then we're going to multiply all of our denominators. And we get 2 times 2 is 4, times 2 is 8. And so it is the answer 1 to the 8th power. Or sorry, 1 to the 8th power. The fraction 1/8. Sorry about that. All right, so we've got 1/2 times 1/2 times 1/2. And we get 1/8 is our final answer. So our 2 answers are these 2. 1/2 times 1/2 times 1/2 is writing it out. And then our answer is 1/8. I like this little note. It says in example 5, the fraction 1/2 is set in parentheses to note that the entire fraction is the base, not just the 1 and not just the 2, but 1/2 to the third power. It says without the parentheses, it was understood that the base is only the numerator of the fraction. So if it was 1 to the third power over 2, then it's not 1/2 to the third power, it's just 1 to the third power over 2. So that'd be like saying 1 times 1 times 1 over 2, which would still just be in 1/2. Not the same answer, okay? When we put the parentheses in there, now we're talking about everything top and bottom being multiplied 3 times, okay? Again, not times 3, but 3 times. I know it sounds weird, but it's different. All right, now I'm going to have you do the got-its on your own again. make sure you pause the video, and when you come back, we're going to go over the answers. All right, here are the answers. For C, we have 10 to the 5th power. So that's going to be written as 10 times 10 times 10 times 10 times 10. The base is 10, and we've done it 1, 2, 3, 4, 5 times. When you multiply out 10 times 10, that's 100, times 10, that's 1,000, times 10, that's 10,000, times 10, that's 100,000, and so our final answer is 100,000. Notice that I've given two different answers here. I wrote out each power as a product with the same factor, and then I found the value. Two different answers. I'm expecting that whenever I see your work tomorrow. For D, we've got 2.1 times 2.1, because that's 2.1 squared. When we multiply that out, we end up getting 4.41. For E, we have 1/4 times 1/4, which ends up when we do numerator times numerator, denominator times denominator, we get 1/16. So it's going to be 1 times 1 over 4 times 4. Example number 6 says the zoo has an aquarium that holds around 7 to the 4th power gallons of water. About how many gallons of water does this aquarium hold? So here's a story where they use shorthand 7 to the 4th powers. If we're going to figure out exactly how many gallons that is going to be, we're going to do 7 times 7 times 7 times 7. Not 7 times 4, but 7 4 times. So 7 times 7 times 7 times 7. So 7 times 7 is going to be 49. And the other 7 times 7 is going to be 49. And so if you'd like to, this is how I like to do it. I like to group things together. And I'm going to multiply this out. 81, 36, 44. Then this is 36. Don't forget your little star here. 3. That was 16, 19. Then we add. And then when we figure out 2,401 gallons of water. All right, so 7 to the 4th power, 7 times 7 times 7 times 7. Here's another got it for you to do. Go ahead and pause, and when you come back, we'll go over the answer. You're doing F. And your answer should be 10,000 lakes. 10 to the 4th power is going to be 10 times 10 times 10 times 10, which is 10,000, and that's the answer. All right, so that finishes up our 6.1 lesson for powers and exponents. Thank you so much. We'll see you in school.